Hello student. In this lecture we are going to discuss about one of the very important topic under the structure, that is the bit field. So far we have discussed about the structures which is basically used to store the heterogeneous type of the data element, and every data element have their different storage. As such, we know that whenever we need to declare a structures, the structures always start with the keyword struct followed by some name. Let's have test, the name of the structures. And in this structure, suppose I have declared the variable like integer, let's have x, let's have float y, and let's have character its name, let's have 5. So as a result, what will happen? So as many number of the variables that will declare, as many number of the attributes that will declare inside the structure, to hold the values in every attribute basically occupy the spaces into our computer memory is a separate, means every attributes will have a separate memory addresses, separate memory spaces. So as a result, so as soon as we declare as a sum of the variables of the structure type, like let's have struct text a and b. Suppose I have declared the two variables of the structure type test. So as a result, what will happen? For a, it will occupy the space into our computer memory, and how many space based on how many number of the attributes, how many number of the variables that has declared inside this structure. So as such, we know that the standard C is basically integers is used to occupy the 2 byte of the space. Float generally used to occupy the 4 byte of the space, even though it is depends upon the compiler and your computer architecture. So but we used to follow the standard of the C, that is NCC, where it has been stated that integers is basically occupy the 2 bytes, whereas the float is used to occupy the 4 bytes, and the character variable used to occupy the 1 byte. So here the name have 5, so total 5 bytes. So as a result, what will happen? Here we have declared the a and b are the two structure variable of the test type. So for a is going to occupy the space for x, for y, for the name, as well as for the variable b, it will also occupy the separate space for x, y, and this name. So as a result, how many total spaces it will occupy? Here we may notice that for a it will occupy 2, 4 plus 5. This means total 11 byte, and similarly for b is also occupy the 11 bytes of the spaces. But at the time of the inserting the record, we may notice that suppose this whatever the variable that we have declared inside this x, these x are going to hold some binary value. Suppose we want to store the data into x either in 0 or in 1. So if you want to store the 0 and 1, so it will only need 1 bit of the information. If to store this 1 bit of the information, we are using the 2 byte of the space. Similarly, suppose in the case of the float y, suppose they have a 4 byte, but we are storing some of the data element which is the size which is required very lesser than the 4 byte, but it will as such the standard of the C will always occupy the 4 byte, so it will also have unnecessary wastage of the storage. So to overcome from this problem, they have one of the important one of the important tools has been designed under the structures, where we can use it only, or we can occupy only that much of the memory space as per our requirement, and this is only possible by the help of this bit field. So how the bit field basically defined? Suppose we want to store some of the data element against this x, either it will be for 0 or for 1. So how many bit is required? Only 1 bit. So here instead of defining this, we can use the bit field, where it can be defined like struct test. So here we may define like 1 bit will be enough. So here we do not need the sign magnitude as well. We do not have to waste any storage for the defining the negative positive value. Here we are going to store either it is true or false, 0 or 1. So here we do not need to use any unnecessary bit for the sign magnitude. So here you may use the unsigned, as such we know unsigned. Here we are going to use the integer, and here we are going to use the variable x, and here we are going to use the store the data element either 0 and 1. So one bit only enough. So here we just specify this 1. So the computer are going to occupy only one bit against the variable x. Similarly, if you want to store some of the other data element where we do not need the 2 bytes of the long as the integer basically occupy, so you can declare as per your requirement. Suppose unsigned integer y, suppose bit field we used to specify based by defining this colon. Suppose 3 means we are allocating the 3 bits against the variable y. Similarly, let's have unsigned int, suppose chat, let's have suppose 7, and close it. So here we have seen that for every variable, so here if you define the variables like suppose struct test a, suppose we have defined a variable a, so for a how many bytes are going to occupy. Here we might notice that if we declare like this, so it is going to occupy 2 4 plus 5 total 11 bytes. But even though if we use this variable for suppose if I do not declare the unsigned as well as do not define the bit field, so for this x it will take 2 byte, for y it will take the 2 byte, for the z it will also take the 2 bytes. So if we define the bit field by specifying the how many bits that we are going to be occupy for storing the data element, and so if you define like this, so in this case it will total take 7, 3 means 10 is 1, total 11 bits. The size of the entire structures is going to be the 11 bits instead of 6 bytes. So here we basically store, where we basically save our computer space by unnecessary wasting of our memories. So here we only need only 11 bits. So how can we find out that how many bits we can use, how many size that it has been allocated? So based on that, we also know that there have a one of the keyword is size of is a keyword which basically help us to identify that how many total size is occupied. So here we can test it by having defining the size of a. You may write like printf %d of size of a. As a result, you could be notice that it will give you the output is 2 if you are using the turbo C or your standard C versions. So you could be notice that if the integers are going to be take the 2 bytes of the long, or here in this case if you define what is the size of this s, it will define this the 2, because the size of is the is a operator which basically returns the value in terms of the byte. So here is 11 bit is more than 1 byte, so it will always return the 2. And suppose if you declare like integer inside j, suppose you have defined if it is suppose it is 2 bits only, so as a result total number of bits will be 3 2 5 and 1 6. So in that case the size of a it will return as a 1. So size of is the operator which basically return the value in terms of the byte. So here if we use only 6 bit, so it is lesser than 1 byte, so it will return 1 byte, and if it is more than 8 bit it will return the 2 byte, like that. So this is the actual flavor of your bit field. The bit field very important to save our computer memory. If you are write the some of the complicated program, or if you are going to deal with some of the problems which are related to the real world, so here every bit, a single bit of the storage is it will be important for us. So to save that memory, we can easily use this bit field. Okay, now other than the bit field, there have another very important user defined data type that is similar to the structure, that is union. The union is also a user defined data type which is also used to store the heterogeneous type of the data element, but there have some of the basic difference with the structure. So as such, we know that the structure is basically used to store the heterogeneous data element, and every data element have the separate memory location. So if as a result that if all the attributes, all the variables are going to have a separate memory locations, and if even at any some of the problems, if we do not use all the variables at the same time, but will have the computer will occupy that much of the space. So again there have the unnecessary the storage of the computer memory. So whenever we will face some situations where we need to store the heterogeneous type of the data elements, some of the data element are integers, some of the data elements are float, some of the data elements is a character, but we do not need all the variables at the same time. So the structures basically waste our computer memory, because every variables will have the separate memory location, and if they have a separate memory location, so it does not necessary whether you will use or don't use, but it will occupy the space. So is there have any other way by which you can save our memory? Yes, the union basically does. So the union is also similar type of the structure. It is also used to store the heterogeneous type of the data element. Especially it has designed for solve those problem where we do not need all the variables under the structures at the same time. Like suppose we have declared a struct. Let's have struct test. Let's have integer x. Let's have float y. Let's have character c. So after this, suppose I have declared some of the variables of this structure type. Let's have structure is a. Now let's have a, or let's have b. I have declared the two variables of this structure type. Now instead of x, y and c, I want to use only the y. So as a result, what we will do, we'll assign some of the values against this y for the variable. Sorry, here there should be test. So a dot y equals to suppose 7.6, or let's have 7.0, and b dot y we are storing suppose 3.0. So as a result, what will happen, out of these three attributes we are only using this y, where the x and c is becomes unused. So but the computer, what he will do, he will allocate the space for x, for y as well as c. So here we are storing, we are wasting the storage of x for the a, as well as we are wasting the storage x for the variable y, for the variable b. Similarly we are wasting the storage c for the variable a as well as for the variable of c. So whenever we will face some of the situations where in the structure where the as many number of the heterogeneous type of the variable that we have defined, where all the variables do not need to access at the same time, we can use the union. So what basically is union does? Union basically is allocate. So if you talk about the definition is concerned, it allocate the common storage space for all the attributes, for all the attributes. So what does it mean? So here instead of if you define the structures, so it will occupy the 2 byte, float y it will also occupy the 4 byte, and character c it will occupy 1 byte. So total is going to occupy the total 7 bytes of the space. But if we define the same things under the union, like union test, let's have integer x, float y, let's have character c. So if you define the variables, let's have the union text, suppose A. So for the A, here is going to occupy only the 4 byte of the space instead of 7. So what does it mean? It means for all the variables, all the attributes which has been defined inside this union, for storing all these attributes is basically occupy a common storage space. And what would be the size of that common space? Definitely it will occupy the larger size which has been defined under this union. So under this union, integer will occupy the 2 byte, float is occupied the 4 byte, and character only occupy the 1 byte. So what is the maximum size that we can allocate for which all the data element can be stored in the same locations is nothing but the larger storage. So as such, we know the float basically have the largest storage space than these integers and character. So the float, if will occupy the 4 byte of the space, so the whole union, if you define any variable against this variable, it will occupy only 4 byte. So as a result, what will happen? We can use this 4 byte of the storage for can use this 4 byte of the storage for the x. So if we are going to use, this is for x, this much of the space for y, and this much of the space for c. So as a result, the union, if we want to access the all the data element at the same time, so you may not get the correct value, because if you want to store the value of y, so it will occupy this much of the space into our computer memory, it will hold, it will store the data element in this byte. And if you want to store again, if you want to store the value of x, so in that case it is going to overwrite in this first 2 byte. Again, if you access some of the values for c, it is going to overwrite of this one. So in that case you may not get the correct result. So if we declare a union, we'll have to give a extra care that the at any instead of the time we can access only one attribute at any time, not all, because every variables are going to have the same storage space. So at a same time only one attributes can be accessed. So whenever we face any situations, or whenever we deal with any such problems where we do not need all the attributes at the same time, where we need to access only a single attribute at any instant of time, you can easily use the union. So the union is also user defined data type as such of the structure, but here for all the attributes as such of the structure, it is going to occupy the separate memory spaces. So as many number of the attribute that will declare, that many number of the spaces it basically occupy, whereas the union basically occupy a common storage space. Now perhaps it is clear. Okay. Now similarly, so if you compare with the structure and if you compare with the structure and union, so we may easily distinguish between these two tools under the user defined data type. Like the structures is a user defined data type, a union is also user defined data type. Structures start with the keyword struct, whereas the union start with the keyword is union. Now in the case of the structures, for all the attributes have the separate memory allocations. For the union, for all the attributes they have a common memory allocations. In the structures, we can access all the variables at any instant of the time, but under the union it can access only one attributes at a time. So this is the basic difference between the structure and union. Okay. So other than this structure and union, which is the user defined data type, there have another user defined data type that basically very useful in C, that is called enum, where the enum is also user defined data type, which is basically used to assign some of the constant value against some identifier. So whenever we want to assign some of the constant integer value against some of the identifier, we can use this enum. So how the enum basically looks like, if you follow the syntax of the enum, as such the structure start with the keyword struct, as such the union start with the keyword union. Similarly, the enum start with the keyword enum, okay, followed by some name. Let's have test. Then we'll have to specify what are the identifier. Let's have, I am going to define some set of the identifier is x, let's have it is y, let's have it is z. So if we define the enumerated or enum user defined data type for the defining the constant value against the identifier. So here we have defined the three identifier x, y and z, and it is basically used to assign the constant value. So what would be the constant value? So if we define the enum like this fashion, the computer by default it start assigning the constant value 0 to the first identifier, next will 1, next will be 2 and so on. So the way that the way we define the identifier, the list of the identifier, the computer start assigning the constant value from 0 onwards. So if we display like printf %d of here x, so you will get the output as 0. Similarly, if we mention printf %d of z, it will give you the output is 2. So what happen if you wants to assign the suppose the user wants to assign some of the constant value by himself other than the 0, he wants to assign the constant value with some of the other values so other than 0. So how can you do this? So for doing this, you may easily define the enum test. You may specify, let's have x, let's have y equals to 5, and let's have it is z. So as a result, what will happen? The x will start as such. We know the computers by default it will start assigning from the 0 and it will start one after another. So x will be assigned by 0, but as soon as we have specified y equals to 5, so here the 5 will be assigned against this identifier y, and for the z it will assign the next constant value is 6 and so on. Okay. Similarly, if we define, let's have enum test, let's have x, y, z, p, q like this. So as a result, suppose here we specify y equals to suppose is 5, and suppose p here we specify suppose 9. So as a result, what will happen? The x computer by default will assign the constant value 0. Here the user have specified y equals to 5, so the 5 will be assigned against the identifier y. Next z is comes after the y, the order of the z is coming after the y, so the value of the z the computer will assign the next constant value, it is 6. Next is p, here we have specified 9, so the against the identifier p it will assign the constant value 9, and q is appear after the 5, so it will store the constant value is 10. So like this. So enum is another user defined data type that is basically used to store the constant value against the identifier. So this is so far, this is the user defined data type. We have discussed about the structures, how the structure basically used to store the heterogeneous type of the data element, then how the bit field can be used to overcome from the unnecessary storage, unnecessary wastage of the storage of different attributes. Similarly, we have declared about the union. So how the union will differ from the structure we have discussed, and what is another user defined data type is enum, and how it is look like and how it works, that we have discussed. So this is also about the user defined data type. This is also about the structures, union and enum. Thank you for your watching.